All right, petrol heads, let's talk engines, specifically combustion engines. These marvelous machines are the heart of most cars, motorcycles, and even some planes. Ever wondered what makes them tick? It all boils down to one word: combustion. Combustion is just a fancy way of saying controlled burning. You see, these engines take a fuel like gasoline or diesel and mix it with air. Then they ignite this mixture, creating a mini explosion that pushes a piston. This piston's movement is what ultimately powers the wheels and gets you moving. Now, there are two main types of combustion engines: internal combustion engines, or ICEs, and external combustion engines, or ECEs. Think of it like this. ICEs are like having a party inside the engine, while ECEs keep the party outside. But don't worry, we'll delve into the nitty-gritty of each type soon enough. For now, just remember that both rely on the power of controlled explosions to make things go vroom. Let's start with the more common type internal combustion engines, or ICEs. These are the workhorses of the automotive world, found in everything from zippy sports cars to lumbering trucks. In an ICE, the combustion party happens right inside the engine itself, within small chambers called cylinders. Each cylinder has a piston that moves up and down like a caffeinated rabbit in a hat. When the fuel-air mixture explodes, it pushes the piston down, creating power. Now, ICEs come in a few different flavors. The most popular are gasoline engines, which are found in most passenger cars. Then there's diesel engines, known for their grunt and efficiency, often used in trucks and heavy machinery. And let's not forget the quirky rotary engine, a unique beast that uses a spinning rotor instead of pistons. No matter the type, all ICEs share the same basic principle: controlled explosions inside the engine create the power needed to move. Now let's break down how most ICEs actually work, using the popular four-stroke cycle as our example. Picture this. Intake. The piston moves down, sucking in the fuel-air mixture like a thirsty hippo. Compression. The piston moves up, squeezing the mixture into a tight space, ready for action. Power. The spark plug ignites the mixture, causing a mini explosion that forces the piston down with a bang. Exhaust. The piston moves up again, pushing the spent gases out of the cylinder like a bouncer clearing the club. And then the cycle repeats over and over again, hundreds of times per minute. It's a beautifully choreographed dance of intake, compression, power, and exhaust, all happening in perfect harmony to keep your engine humming. So ICEs are pretty clever, right? But like any good party, they have their pros and cons. On the plus side, ICEs are relatively cheap to produce, offer decent fuel economy, and pack a good punch for their size. However, they're not perfect. ICEs can be noisy, produce harmful emissions that pollute the environment, and rely on fossil fuels, which are finite resources. Plus, they can be a bit thirsty, especially when you put your foot down for a bit of fun. Despite their flaws, ICEs have been the dominant engine type for over a century, and for good reason. They're powerful, adaptable, and relatively affordable. But as we become more environmentally conscious, the search for cleaner, more sustainable alternatives is well underway. Section 5, outside the box: external combustion engines. Now let's step outside the combustion chamber and explore the world of external combustion engines, or ECEs. Unlike ICEs, ECEs keep the combustion party separate from the power generation. Think of it like this: instead of having a bonfire in your living room, you have it outside and use the heat to boil water for tea. ECEs work by burning fuel in a separate chamber, which heats up a working fluid, usually water. This hot fluid then expands and drives a piston or turbine, generating power. The most common examples of ECEs are steam engines and steam turbines. While not as widespread as ICEs in vehicles, ECEs have their own unique advantages. They can run on a wider variety of fuels, including biofuels and even solar power, making them more versatile and potentially more environmentally friendly. Section 6. Steam giants from trains to turbines. Let's rewind the clock a bit and talk about the granddaddy of ECEs, the steam engine. These mighty machines powered the Industrial Revolution, driving everything from locomotives to factories. Steam engines work by heating water in a boiler to create steam. This high-pressure steam then expands and pushes a piston, which turns a crankshaft and generates power. While they may seem like relics of the past, steam engines are still used today in some industrial applications and even in a few niche vehicles. Then we have steam turbines, a more modern take on the ECE concept. Instead of pistons, steam turbines use a series of blades mounted on a rotor. As high-pressure steam flows through the blades, it causes the rotor to spin rapidly, generating power. Steam turbines are widely used in power plants around the world, converting heat energy into electricity. Section 7, ICE versus ECE, a tale of two engines. So, which type of combustion engine reigns supreme? Well, it's not a simple answer. ICEs and ECEs each have their own strengths and weaknesses, making them suitable for different applications. ICEs are generally more compact, lighter, and have a higher power-to-weight ratio, making them ideal for vehicles. They're also quicker to start and respond more rapidly to changes in speed and load. However, they're less fuel efficient than ECEs and produce more harmful emissions. ECEs, on the other hand, are known for their efficiency, fuel flexibility, and lower emissions. They're also quieter and produce less vibration than ICEs. However, they're bulkier, heavier, and slower to start, making them less suitable for mobile applications. Ultimately, the choice between an ICE and an ECE depends on the specific needs of the application. Section 8. Combustion today, where the engines roar. Despite the rise of electric and hybrid vehicles, combustion engines are far from extinct. They still power the vast majority of cars, trucks, ships, and planes around the world. Gasoline and diesel engines remain the workhorses of the automotive industry, while jet engines, a type of internal combustion engine, rule the skies. Steam turbines continue to generate a significant portion of the world's electricity, while smaller combustion engines power lawnmowers, generators, and other tools. Even in the face of increasing environmental concerns, combustion engines continue to evolve and adapt. Manufacturers are constantly working on improving fuel efficiency, reducing emissions, and exploring alternative fuels to make these engines cleaner and more sustainable. Section 9. Greener combustion, cleaning up the act. As the world shifts toward a greener future, the pressure is on to reduce the environmental impact of combustion engines. Thankfully, engineers and scientists are rising to the challenge, developing innovative technologies to make these engines cleaner and more sustainable. One major area of focus is improving fuel efficiency. By designing more aerodynamic vehicles, reducing engine friction, and optimizing combustion processes, manufacturers are squeezing more miles out of every gallon of fuel. Another key area is reducing emissions. Advanced exhaust after-treatment systems, such as catalytic converters and particulate filters, help to scrub harmful pollutants from engine exhaust, making the air we breathe cleaner. Section 10. Electric dreams, hybrid hopes, the future of getting around. While combustion engines continue to evolve, the automotive landscape is undergoing a seismic shift towards electrification. Electric vehicles powered by batteries and electric motors offer a zero-emission alternative to traditional gasoline and diesel cars. Hybrid vehicles, which combine a combustion engine with an electric motor, offer a bridge between the two technologies, providing improved fuel efficiency and reduced emissions without sacrificing range. While electric vehicles and hybrids hold great promise for a greener future, combustion engines are likely to remain a significant part of the transportation mix for many years to come. Their affordability, range, and existing infrastructure make them a tough act to follow. Section 11. The road ahead, combustion engines in a changing world. So, what does the future hold for combustion engines? While their dominance may be challenged by electrification, these versatile machines are far from finished. They're likely to remain a crucial part of the transportation and energy sectors for the foreseeable future, especially in applications where range, affordability, and infrastructure are key considerations. As technology advances, we can expect to see even cleaner, more efficient, and more sustainable combustion engines emerge, powered by a mix of traditional fuels, biofuels, and potentially even hydrogen. The road ahead may be filled with exciting new possibilities, but one thing's for sure: combustion engines, in one form or another, will continue to shape the world around us for many years to come.